Today we're going to take a look at radical expressions and then rational exponents. We're going to be able to write these and rewrite these from one form to the next. And then we're going to work on evaluating and solving and then doing a real-world application for these. We will be working out of your student companion book, and these answers will be recorded into a Delta Math assignment I've created. All right, what we're going to take a look at today is working on radical expressions. We're going to deal with radical expressions that you're familiar with, like square roots and even maybe cube roots, but we'll go even further and do even higher roots than that. So let's just jump right into it. What we're supposed to do here is find the specified root for each number. Well, the first one says find the fourth root of 81. So when we have that, the fourth root of 81 looks like this. Now, there's a few ways we can do fourth roots. Now, a fourth root is the square root of the square root, if that helps you as you go through these. So like on this one, I'm going to show you two ways. One way you can check to see if it has a perfect fourth root. The square root of the number would be 9, and then the square root of 9 would be 3. But we can also do the prime factoring tree like we did earlier. And when we, instead of looking for things to pair out, what we're going to do is look for things that come out in fours. So we see that 9 factors down to 3 times 3, and then 9 factors down to 3 times 3 as well. So what we're looking for is a group of 4, since we have a fourth root. That's called our index there. So we do have a group of 4 3s, which means the fourth root of 81 is equal to 3. And as we said, that was the square root of the square root. Now, as we look at the cube root of 64, we're going to break this one down the same way, but since it is the cube root, we're looking for sets. That would be 3. So let's break down our 64. We can come in here. We can do this any type of way. If I said 32 times 2, this is going to be a longer way of doing it. And then I go 4 times 8. This is 2 times 2. This is 4 times 2. Mark these out as I go. And then this is 2 times 2. So this is the prime factors of 64. We have a third root, which means they have to escape in 3s. Well, I have 1, 2, 3 sets of 2. So that would be 2. We have a second 1, 2, 3 set of 2. So we get to pull that out as well. And you see every branch of this factoring tree has been used. So there will be nothing left under the radical. If there was, we would leave that number underneath of the radical. So 2 times 2 is 4. So what we've learned is the cube root of 64 is 4. I've added this slide to your Canvas page. It is a very useful slide. You should take a look at these. These are conversions from a rational exponent, that means division in the exponent, to a radical form, because they are the same thing. It's very important that we be able to move these from one to the next. You can see these conversions and you can see these examples. I'm going to use this a little later. I will reference this sheet, and this is the one I'm talking about. Primarily what I want to highlight is our bottom section here. And these are our conversions from a radical form that is using a square root form. And you can see this here. And n is the index, the c is the base, m is the power. This n value is always going to become, the index is always going to become the denominator to the exponent. The power that is inside of that, m, will be the numerator, and this value called that c is known as the radicand, will always be the base of this exponent. And then as you can see, this is just moving the opposite direction. the n becomes the index, the m becomes the power, and the c becomes the radicand. So you can use this sheet to go back and forth and get as a reference point for the rest of the assignment. So as we take a look at this, what we're being asked to do is to convert a fractional exponent into a radical. Well, what we learn is that this can be turned into a radical exponent, and it looks like this. Whatever value is in the denominator of the exponent, I'm going to rewrite that to make sure that you understand fully what it's saying. It's 25 to a 1/2 power. But that number that's the denominator is always going to go in this spot right here, which is called the index. Now, the value that is the base of the exponent is known as the radicand. It is going to be right there. And then the only other part we haven't touched is the numerator. The numerator to the exponent is 1. It actually can go in one of three places. It can be attached to the 25 like this. It can be put right outside the radicand like this, or it can be put as a parentheses. Now, it's to a 1 power, so it really doesn't matter much where it goes because the 1 is not going to affect it. We also don't need the 2 because the square root is understood. So the square root of 25 is plus or minus 5, but we are just going to worry about our positive versions of the answers today. So let's look at this conversion that we need to do with the 32 to the 2/5 power. Well, this is a fifth root because it has a denominator of 5, so the 5 will go right there. The base is 32, so that will become the radicand. And then the power of 2, the numerator of 2 will become the power of the radical. I happen to know that 32 has a fifth root, so I'm going to write it this way. Now, if you're not aware of that, what we can do is come down here and break this into a prime factor. Well, 32 is 4 times 8. 4 is 2 times 2. And remember, since this was an index of 5, we need these numbers to escape n values, groups of 5. So 8 is 4 times 2, which is 2 times 2. And we're looking for a grouping of 5. Well, there's 1, 2, 3, 4, 5. So the fifth root of 32 is just 2. The fifth root of 32 is just 2. Well, we still have the power to the outside, so what we essentially have here is 2 squared, and our result is 4. So 32 to the 2/5 power is 4. So it says in this habits of mind, generalize, what is true about the denominator of a fractional exponent in which the absolute value must be considered? Well, it's a relationship that we need to consider actually. If I have a base of x, and let's just call the numerator n and the denominator d, just to keep it straight there. If the numerator is greater than the denominator, well, we have a mixed fraction if that happens. So if the numerator is greater than the denominator, what's going to happen to the x value? It will increase. So we'll go from a smaller number to a larger number. On the contrary, if the denominator is greater than the numerator, say fraction between 0 and 1, the x value, that's our base, will decrease, excuse me. So our values are based on the denominator and the numerator, the relationship between the two. So we're going to rewrite each of these just for practice sake. But what you need to understand is that these values can be put into our calculator either way that you're familiar. So what I'm going to do is I'm going to rewrite this as the negative sign is going to be there. Since I have an exponent with a denominator of 4, my index is 4. And then the 16 to the third power. This is generally what I would do on this value, is I would take the power of 16, the third power of 16, get that value, and then find the fourth root of that. Now, I don't need to worry about that because I've already typed this in my calculator. The result of all of this, when it goes into my calculator, is actually -8. It's actually 8, but the negative sign in front then makes it a negative. And as we move to the next one, again, we're going to make the conversion even though it's not necessary to make the conversion. But just for practice sake, we're going to make the conversion, but this can go into our calculator. So the radicand is 3.5. That is our index. Excuse me, that is our base value. The index is 5, which means that will be the denominator of the exponent. And then the power of the radicand is the numerator of the exponent. When we put all of this in our calculator, it actually comes out to an irrational number. So we want to use the number 2.724. Notice I use the approximation sign because it's not an exact answer. You also notice it said round to the hundredths place. I just went one step further on this. If you put that into Delta Math, it would be right as well. But that's actually the hundredths place. All right, now it's time for the fun stuff. What you need to recognize on this, when we have multiple terms, or it's one expression under there, but if we have these terms, each of them are getting a cube root in this case. You do not have to rewrite, but I'm going to rewrite this. This is essentially saying the cube root of -8, the cube root times the cube root of a to the third power times the cube root of b to the 9th power. So what you need to understand is when we are taking a root of a power, what essentially is going to happen is division. Now in the first part, the third root of -8, remember, we can't take even roots of negative numbers, but we can take odd roots of negative numbers. So the cube root of -8 is -2. We're going to multiply this times a. Let's convert this back to a fractional exponent. I won't do this all the time, but this is just so we can see how this works. This is equal to 3 divided by 3. Because we have an index of 3, which is the denominator, and we have a power of 3, which is the numerator. And we all know that 3 divided by 3 is 1, but we'll take care of all this in one line. So we move to the b. Well, the b has an index of 3, so that would be the division part, and it has a power of 9, so that would be our numerator. You can do this math in your head. I'm perfectly fine with that. This is not work that I need to see, but if you want to do it, you can. So what we get here is 3 divided by 3 is a to a 1 power essentially, but we don't have to say 1. And then we have b to a 9 divided by 3. Well, 9 divided by 3 is 3. So our answer is this, -2ab to the third power. So in this one, we're going to do the same thing, but it's got an index of 4. So we're going to need things to escape in 4s. So this is the fourth root of 256. This is the fourth root of x12. So basically 12 divided by 4. And the fourth root of y divided by 24. Well, the fourth root of 254 is actually 4. The x values will end up being x to the 12 divided by 4 because we have an index of 4 and a power of 12. And then the y's will be 24 divided by 4. So we end up with 4 x to the third power y to the 6th. Now the solving. Solving, a lot of fun with the solving. We just need to make sure we do the reverse of the order of operations. Our focus is mainly on the x value. We have to unpile everything off of our x value, and we want to start with the easiest math and work our way back from there. So if there were adding or subtracting outside of a parentheses, we would take care of that first. Then we would remove any multiplication or division, and then we will always finish with a root or power if needed. Those happen at the same time. So on this one, we have no adding, so there's nothing to add, so we're going to divide by 5. So when we divide by 5, x cubed becomes 64. 320 divided by 5 is 64. So the way we get rid of the cube is to use a cube root. What we do to one side, we have to do to the other. So the cube root of x cubed is x. The cube root of 64 is 4. So this is how we solve radical expressions. So we've got one more solving here. We have 2p to the 4th power is equal to 162. There is no adding or subtracting here, so we get to jump straight into division. We divide both sides by 2. Our p is equal to 16 divided by 2 is 8. 2 divided by 2 is 1. So we get the 4th power of p is 81. We get rid of a 4th power with a 4th root. And we've already done this number earlier today. The 4th root of 81 is 3. And we're going to stick again to all of the positive stuff just for today. But that is a plus or minus value as well. All right, so as we take a look at this one, what we see is it says 1 cube has an edge length 3 centimeters shorter than the edge length of a second cube. The volume of the smaller cube is 200 square centimeters. What is the volume of the larger? The thing about a cube is all sides are the same. So the volume of a cube is length times width times height. And all of them are the same. So essentially what we have on volume of a cube is whatever the length of the sides are, cubed. Because length and width and height are all the same. So in this case, the smaller of the cubes has a volume of 200 square centimeters. So if we can find its side length, we can then work towards finding the larger one's side length. So we take the cube root of this number, and just so you know, those of you that are using a TI-84, where you find the cube root is under math, and then it is option number 4. So math option number 4. So the length of the smaller side is going to be 5.85. And this should be an approximation sign because it's actually not exactly that. We've got, looks like an irrational number. So this is a rounded number. Remember, we put those approximation signs. So we find the approximation signs to indicate that, hey, we have rounded. So this is the smaller. Well, if the larger one has sides that are 3 centimeters, it says the smaller are 3 centimeters shorter. So obviously, to get to the larger one, we take our number and we add 3. So what we learn is the length of the side of the larger cube is 8.85. And if we're trying to find the volume, we will have to cube this number. So we take that number to the third power. And the result is 692.69. And this is going to be centimeters cubed. So that would be our volume. So we're going to take this one step further, and we're going to add a K to this. Because we will run into some of these where you have to add on either side. So our steps are always going to be, number one, adding or subtracting the K value to isolate the X value. So that would be step 1. Step 2, we will, it's actually multiply or divide, but the way they have this one set up, we will divide by A, but just recognize that if it was division, the step we would take is multiplication. And then step 3, the final step would be to take the nth root. Depending on what the power is that we see up here, will be the result, will be the one that we use. So if it's a 4th root, we will, 4th power, we will take a 4th root.